Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about Oxepine and Thiepines. First, we have to correct the spelling of Oxepine, Oxepines, Oxepines, and Thiepines, Thiepines. So pins, pins in both, and oxy and thiepine, oxepine and thiepine. So you can see the structure of oxepine and structure of thiepine. Both compounds have 7-member heterocyclic compound. You can start numbering of these two structures with oxygen in case of oxepine and with sulfur in case of thiepine. The structure related to 1H-azepine that bear an oxygen atom is known as oxepine, while sulfur atom is known as thiepine. It is clear to you. These are class of oxygen sulfur containing 7-membered heterocycles with molecular formula C6H6O C6H6S. These heterocycles has 8 pi electron and obey 4 n pi electrons rule, hence anti-aromatic in nature. For multiple choice question, this is very important. Oxepine and thiepine. Now, as you have seen in azepine, oxepine and thiepine exist in non-planar conformation and are non-aromatic compound. Both conformation, you can see here chair conformation. Oxepine is much more stable than thiepine and has been synthesized, isolated, and characterized at room temperature, while thiepine has not been detected. I hope this concept clear to you. What is the concept? Azepine, thiepine, oxepine exist in tautomeric form. Now, oxepine. Due to instability of most monocyclic, oxepine does not have any commercial application, but they do play a remarkable role as intermediate in biosynthesis and metabolism of natural product and xenobiotics. My friend, oxepine at room temperature exists in rapid equilibrium with its valence tautomer, benzene oxide. You can see here how oxepine under equilibrium, rapid equilibrium, it gives benzene oxide. Monosubstituted oxepine support the existence of two enantiomers in equilibrium with the oxepine. Benzene oxide, it is under equilibrium with the oxepine, and this oxepine is under equilibrium with the benzene oxide. Now, my friend, oxepine benzene oxide ratio depends on temperature, solvent, and substitutions. Oxepine form favored in less polar solvent, while at low temperature the benzene oxide is preferred form. So this sentence is very important for your MCQ question, multiple choice question. You can see the oxepine less polar solvent, it gives benzene oxide, and lower temperature it gives benzene oxide. Substitution at C3 favored benzene oxide tautomers, while substitution at carbon 2 and carbon 4 favor oxepine form. So this is also very important point. You should note it down. You can see the conversions of benzene oxide if substitution C3, which is more favorable than carbon 2 and carbon 2 substitution of oxepine. Now synthesis. Synthesis of oxepine from cyclic compound. 3, 4 and 6 member carbocycles have been employed as a starting material for the construction of oxepine ring system. My friend, most synthetically useful method involves cyclopropane and cyclohexanes as a starting material. The most efficient method for synthesis of dihydro and tetrahydroxypene involves ring expansion of alkynyl cyclopropyl carbenols. So you can see the scheme. 3 member carbocycles, it undergo reactions, it give ketoform, and then this 3,3 sigma-tropic rearrangement, it gives oxepine structure. Now 4 member carbocycles, the method bicyclo-2,2,0-hexa-2,5-diene undergo epoxidation. You can see here the epoxidation formation, followed by rearrangement of the resulting tricyclic leads to the formation in low yield of oxepine. Now 6 member carbocycles. My friend, the formations of the oxepine ring from 6 member carbocycle is one of the most useful route to monocyclic oxepine. The method is based on the epoxidation and bromination of 1,4-cyclohexadienes. The dibromoepoxylates, when subjected to dehydrohalogenation condition, afford the corresponding oxepine benzene oxide, and these tautomers rise to oxepine. So you can see the reaction scheme: epoxidation, bromination, dehydrohalogenation, and formation of oxepine. The electronic structure of substituents in the cyclohexadiene ring determine which of the 2 possible substituted oxepine is found. Which 2 possible substituted oxepine is formed, and this depends on which of the 2 double bonds are initially involved in the epoxidation. So if substituent is electron donating, then it leads to formation of 2 substituted oxepine. So you can see the reactions with the RCO3H, formation of epoxide, bromination, base, and then ring expansion, formation of 2 substituted oxepine. If substituent is electron withdrawing, then it leads to formation of 4 substituted oxepine. You can see the bromination, base, and ring expansion, 4 substituted oxepine. Now photochemical and thermal reactions. My friend, the parent oxepine can be prepared by a short and efficient route starting from 7-oxanorbornadiene as the 5-membered heterocycle. Isomerization of this bicyclic compound into monocyclic oxepine is promoted photochemically, and this followed by thermal rearrangement. You can see here the formation of oxepine. Several di, tri, and tetra substituted oxepine have been prepared using this approach. So this alteration of substituted furan with alkyne via corresponding 7-oxanorbornadiene. Then you can see the 4n+2 rules. Then it undergo photochemical reaction. On heating, it gave the ring expansion oxepine. Now reaction of oxepine. The existence of rapid oxepine benzene oxide equilibrate relation does not allow oxepine to be treated as separate entities, and some reactions may involve the benzene oxide tautomers. You can see the existence of oxepine. First, cycloaddition reaction. Oxepine undergo a cycloaddition reaction with unsaturated molecules due to their cyclic polyenic character and can behave as an ene, diene, and triene according to kind of dienophile and considering the oxepine benzene oxide system. Oxepine react with the malic anhydride to form 4+2 cycloadduct, while benzene oxide react with DMAD via 4+2 cycloaddition to form corresponding product. So you can see the reaction scheme starting with the oxepine forming this adduct. It undergo benzene oxide and then formations of adduct. Reaction with electrophile. This is also very important. The protonation of oxepine benzene oxide takes place at the ring oxygen atom and generally results in the CO bond cleavage with the formation of carbocation before conversions into phenol. So you can see the conversion of oxepine in benzene oxide and the formation of this. It undergo 1,3 shift -R 1,6 and formations of different types of phenol derivative. Reaction with nucleophiles. My friend, the arenes oxide valence tautomer of oxepine could react with nucleophiles as a simple oxide. Note it down. However, the oxepine benzene oxide is quite unreactive towards the nitrogen nucleophiles like NH3, NH2 minus or NH2, but react with azide ion. So, oxepine undergo benzene oxide and then ring open. Now, thiopine. Thiopine theoretical study at high level of theory dealing with the stability of thiopine and its valence tautomers have shown a significant preference for the valence tautomers benzene sulfide, which was more stable than the parent thiopine. My friend, you can see the remarkable difference with the acepine or oxepine is that valence isomer is simple thiopines are prone to extrude the sulfur atom in an irreversible process. Now, synthesis of thiopine. Thermal rearrangement of cis-1,2 divinyl thiene, thiene means 3-member ring, leads to the formations of corresponding 4,5 dihydrothiopine. You know, thiopine appears to exist exclusively in these valence isomers. The stability of thiopine is enhanced by the presence of bulky substituents at carbon 2 and carbon 7 position and electron donating or withdrawing groups. Additional stability is achieved in the transformation to SS dioxide sulfones and thiopinium salt. So simply you have to practice this conversions of open to ring system. Now, cycloaddition reaction. The cycloaddition of 2,7-di-3-butyl thiopene with tetracyanoethylene TCNE produce only the cycloadduct. You can see the after product 7-member sulfur containing thiopene. Thermal reaction. The most common thermal reaction of thiopene is the reaction of sulfur atom. A similar reaction occurs with the thiopene 1 oxide and 1,1 dioxide, which lose sulfur monoxide and sulfur dioxide respectively. You can see the formation of benzene, sulfone, sulfoxide. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.